In this module, we're going to discuss regular expressions, or regex for short. You can come across regular expressions when doing code reviews on either front-end code such as JavaScript or any back-end code such as PHP, Python, Ruby, etc. Pretty much all modern languages have support for regex. You can also assume that regular expressions are in use when doing black box testing and the source code is unavailable to you. So what is regex? Regex is for finding patterns in strings which are a little bit more complicated than just a standard if statement. So for example, if you had if string equals and then value, that would be a really easy one-liner to do. But then also you have useful functions in different languages for finding strings within a string. So for example, in PHP, you have the string function where you can pass in your string and what you're actually searching for in there. Same goes for JavaScript as well. You can have the string dot includes and then the value that you're searching for in there as well. Obviously, there's multiple different examples we could give on here. But where regex is really powerful is, what if it's just not as simple as this? What if you want to check for an exact pattern? So a really useful website for doing this is a website called regex101.com, where you can test different patterns against different strings. So just in this example at the moment, we're on regex.101.com, and we're going to search this large text string, for example, for people's first names and last names. But you're only interested in finding the names which are Adam Smith or Adam Jones. So let's first put in our test text. So there's a hacker called Adam Smith, there's a developer called Adam Jones, there's a tester called Adam Blake, and there's an admin called Ben Adams. So here, this is where we get to put in our regular expression. So if we wanted to search for any instance of the name Adam, we could easily just type it in here. But as mentioned before, we're going to be looking for Adam Smith or Adam Jones. So we can do a space on here, and you can see straight away that's actually removed the Ben Adams, as there is no string with Adam and then a space after it here. So next we're going to put in a group selector, and we want the names Smith, and then we can use the pipe character as well as a or statement, and then we're going to put in Jones as well. So you can see the only two selections in here is the first and second line, which is Adam Smith and Adam Jones. Adam Blake has obviously been ignored because his name isn't in this group selector. And of course, Ben Adams is not selected because Adams is the last name and not the first name. So now we've got a little bit of a basic understanding of what regex can do. How does this translate into the information security world? So let's say we have some JavaScript which receives a post message request. To make that secure, we need to make sure it only comes from sources that we trust. And to do that, we'd need to check the origin of the domain of the website which opened that browser window and sent the post message request. So don't worry if you haven't looked into post message at the moment. We'll explain that in a different module. We just want to understand at what part it's using regex. So let's say we only want to have requests from app.protected.com. So in the post message code, you would see something like the following. So you'd have an event listener, which is looking for the message type. And then in here, you can see the regex string and the test against the message.origin. Message.origin will contain the domain name of the browser window which opened that page and sent the post message request to it. So as you can see, anything in here has to equal app.protected.com. But it's not actually as simple as that. So let's take the app.protected.com and that's what we're going to be searching in the string for. So if we type in app.protected.com here, you'll see that we've got a match, as that's a perfect match to what our regular expression is looking for. And you can see in this window on the right hand side the match information as well that we've selected. The problem with this is this regular expression is actually open to manipulation. So the first thing that we're going to show you is how you can actually append something afterwards in your payload. So you've got app.protected.com, but you could also actually add .hacker.com afterwards. So as you can see, this is still actually performing a match against the regular expression, and that we have that match there of app.protected.com. So if this was in an if statement to protect some code to say whether the regex has matched, then we can proceed, you would actually see that this would proceed to the protected code, even though the request came from app.protected.com.hacker.com. So what the developer would actually need to do to protect this is to add a $sign to the end of that regular expression. So that actually says, cut off from this point. If there's any more text after this, then it's invalid. It has to end in the .com. So let's remove the .hacker.com off then, because we know that's not invalid. And again, we've got a correct regex pattern because that's now matching. But we could actually add things to the beginning of this as well. So we could add dev.app.protected.com. So obviously protected.com is a domain that we can't control, but there may be other subdomains such as like quality controls, quality assurance, testing, development, etc., which lie before the .app. And these tend to not have as many protections as the actual production domain. So we could find something on there such as a cross-site scripting where we could actually launch an attack from. And because dev.app.protected.com actually still matches this pattern, we could get that to run. So a developer can protect against this by adding the caret symbol at the top, which is the up pointing arrow. And that says that the string has to start with the app part, so we can't have anything before that. And you'll see this is now protected. So there's one last thing, which is a problem with this code, is that the dot symbol, it doesn't just signify a period in between the subdomain and the domain. It's actually a pattern matching character within regex, which says it will match any character except for line terminators. So you could have anything in there. So if you swapped this to an X, for example, you could have appxprotected.com. So this could be a domain that you register yourself, and you could launch a cross-site scripting attack to then run your own code against that target domain. So that's regex in use on a front-end environment in JavaScript, for example. But now let's have a look at a different vulnerability where the URL that we're passing in is actually processed on the back end. So let's say this could be a web form that you complete with a hidden field which passes a domain name in there. And because the developer is using a dry methodology, which means don't repeat yourself, they'll be using a script that they can run over and over again in different environments. So they're going to have like a bit of a catch-all on their regex so they can match multiple patterns so they don't have to keep on repeating it again and again. So let's have a look at this first one. So let's just delete our test information here. Okay, so in this instance, we're going to check URLs that come into this form. So for example, we're going to check URLs that are passed into this form, which then the application is going to use to send data to. So the first thing it's going to look for is either HTTP or HTTPS as allowed protocols. And then we've got the colon, and then we've got the 2 slashes. Now here we actually do have to backslash these as well, because these are reserved characters in regular expressions. So we've got the HTTP or HTTPS protocol. Then we're going to take a group which accepts multiple subdomains. So let's open up the group. Then we're going to allow certain characters. So for example, we're going to allow A to C, 0 to 9, and it must be at least 1 character long. And then we've got the dot and then protected.com. Okay, so let's put in some test strings on here to test it. So we're going to put HTTPS, and then we're going to put app.protected.com. Okay, and that's a perfect match. So if we pass this string into the application, it wouldn't reject it because it matches this regular expression. But like before, we can see that there's no protection against the end of it. So we could actually pass in .hacker.com. And we can still see that this group is matched and it would pass this test. Then it may actually send some data to app.protected.com.hacker.com. This could even include some, say, like API keys or some secrets that the developer didn't want anyone else to know about. So the first thing that I want to do is put a $sign here as well to make sure that there's nothing coming after that. Now we can see that that's actually broken the regular expression. If we delete it, it's matching again. But also we could actually add a URL at the beginning. So let's put our own https hacker.com, and then we can actually add this end part as a query string. So it's still actually matching the regular expression that somewhere in that string it has to be HTTP or HTTPS, any subdomain, .protected.com, and then ends at that point. So this perfectly matches it, so the data would be sent to hacker.com with a query string of the protected regular expression. And again, to protect this even further for the developer, let's add the caret at the beginning to make sure that it begins with the HTTP and then the subdomain protected.com. So again, now we've added this, you can see that our payload is broken. If we remove it back to its original, it's working again. As you remember again in the previous one, that these period symbols actually need to be escaped, so they're not just classed as any character. So you could change this to app.protected.com to appx.protected.com, which is again a domain that you could register yourself, and then you could potentially steal those secrets against your own domain. Another thing that you could test for with regular expressions is putting the @ symbol in here. So let's go for a bit more of a simple one of, let's say, app.production.protected.com. So let's put our $ at the end, and then also the caret at the beginning, so we know it has to. So we know we have to start with that as well. So we have the app.prod.protected.com, and you'll see that's a perfect match. What you could also do is add an @ symbol in here as well. So what that does is, by adding the @ symbol, if this was used in a HTTP call, it would actually deem this as basic user authentication. So it would turn this request into something like https app@prod.protected.com. So it would actually send this as a username to prod.protected.com. But again, if we had access and we could change this, we could change it to an X here, for example. So if we created the domain prodxprotected.com, it would then send this request to app as the username to prodx.protected.com. So again, we could actually potentially steal some information that's in there. That's also another one to try. So hopefully in this lesson, you'll have had a good introduction to what RegEx does and what developers use it for, and some of the ways that you can actually bypass the security.